Okay, we're going to now use historical data and statistical methods to predict future cost in this section covering parametric cost estimating. Our first topic in 3.4.1 is power sizing, and we're going to look at a relationship like this over CB equals power relationship, SA, not X, SA over SB raised to the X. So here, CA is a cost for plant A, if you're creating new plant, construction plant, manufacturing plant, and CB is, or power plant or something like that, CB is the cost for plant B. SA is the size of plant A relative to SB, the size of plant B. And X is the cost capacity factor. It reflects economies of scale. So like the cost advantage when production increases in lines with the increase in the large number of goods. So let's look at an example. Suppose you have an aircraft manufacturer. So suppose you have an aircraft manufacturing plant that wants to build a new 600 megawatt fossil fuel plant to produce its new long-range aircraft or something. And historically, a 20 megawatt plant cost $100 million 20 years ago. And back then, 20 years ago, the cost index was 400. Now the cost index is 1200. And note that the cost capacity factor is 0.79. So what is the cost estimate of the new plant? And let's call that CA. So we got a couple things going on. First off, we have a 600 desire to build a 600 megawatt plant. And in the past, we only had a 200 megawatt plant, and we had the cost of that 200 megawatt plant. So we have to figure out the cost of a 200 megawatt plant today, so we can stick it in here, and then we can compare using the ratio of the plant sizes and our index, or our capacity factor, X. We can calculate what our new estimate for the plant is. So the first thing we need to do is figure out CB. Well, from equation 3.1 before, earlier in the section, in the chapter actually, we found that Cn, which we're going to call Cb here, equals some Ck times I, an index factor over the K index factor. So in our case, Ck was 100 million from up here, and the index we're going to use is our 1200 over 400. So we pull those from here, our cost indexes. And that can give us now a CB equal to 300 million. Now we can plug that into our current equation here and figure out the cost of our new plant. So we've got 300 now times, so our size comparison is our new plant is 600 megawatts over the 200 megawatt size, and we're going to raise that to the power of 0.79, which was also given up here, and do the calculations, and we end up with an estimate of $714 million. Okay, in our next example, or section actually, we're going to look at a learning curve approach. Essentially, we're going to increase worker efficiency and organization performance with respect to repetitive production of goods. So the more you do something, the quicker or the better you should be at doing it. And that's the what we're going to model in this section. So we're going to assume a constant % reduction as the number of units produced doubles in our model. And our model is Z sub u equals k times u to the n. And here n is going to be represented by log of s over log of 2. And s is a learning curve slope parameter. It's a decimal. U is U is the base here, not the exponent, but U is the output unit number. And Z sub u is the number of inputs to produce the first output. So say you're building Formula One cars, and the time to assemble first car, so time for the first assembly, is 100 hours. Then, as output is doubled, the time to complete the car is reduced by 20%. So we can say S then equals 0.8. And so that's our learning curve parameter, learning curve slope parameter. So what's our time estimate to build 10 cars? So Z of 10 equals K U to the N equals 100. And I noticed a mistake. I mislabeled this. We need actually a K up here. And this is K, not ZU. ZU was our final output. So in this case, K is 100 for 100 hours for the first car, and then we have U raised to the power of log of 0.8 over log 2. The number that we want to produce here is 10. So doing this calculation should give us 110 raised to the power of minus 0.322, and this equals 47.6 hours. Okay, the last section in this chapter deals with cost estimating with curve fitting, and that's just simply taking data and using, say, software like Excel and fitting curves to it, and then using that to predict future events using the equation of the curve you fit to predict future events.